Thank you for joining me so early in the morning. This is ungodly early for me, based in San Francisco, so I'm glad y'all are strapping in. We're gonna speed run some parts of this, but videos will be posted in case you don't understand what I'm saying. Okay, so let's just go ahead and get started. So if you're here in this room, you're here just now. Room check, right? Make sure you're in the correct room. We're here to talk about a few things. Number one, problems in MLOps and with MLOps. Number two, we're going to talk about some common tools that are kind of being used in some stacks. We're going to specifically focus on open source tools, especially ones that have kind of come up in the last 2-3 years that maybe y'all are not familiar with or just need to be reminded about. And then we're going to, at the end, I'm going to talk about some stacks that I think folks can kind of like customize and personalize in a very pragmatic way to like y'all's particular needs. Okay, so how are we gonna do this? I'm gonna remind us of what were the original promises of MLOps, like what are we actually supposed to be doing? We're gonna talk about like what are the actual like pain points or where are the jobs to be done by data scientists. We're gonna describe the kind of different requirements of like if you're a solo data scientist, you're a data science team, or even a data science org in an enterprise company. And then I'm going to propose some stacks, which, they could be implemented in a week and even a day, but your mileage will vary. Okay, so first off, who am I? So my name is Mikiko Bazeley. You can call me Mickey, like Mickey Mouse ears. So I'm currently head of MLOps at Featureform, which is an open source feature store. In my role there, I get to work with a variety of different companies, both international enterprises to even startups, who are all kind of figuring out this first question of how do we design our ML platform. Before I was at Featureform, I was working on the platform team for MLOps at Mailchimp. As a matter of fact, I have a former colleague, Emily, who will be doing 2 talks from now. So you should stay in this room and listen. She is awesome. Before MLOps at Mailchimp, I was doing various roles, working either data science, data analytics, or what I like to think of it as working the full value chain of data to ML. I've also worked at a bunch of different startups and all that. Other fun facts, I am based and born and raised in San Francisco. My quarantine habit that I picked up was customizing sneakers. So I just have a bunch of random janky Jordans all over my apartment. My partner cannot stand them, especially since I keep buying more. I do write a lot. I am very interested in a lot of these topics in an almost unhealthy fashion. So just check out my Substack if you're really interested. And I studied anthropology in college. So studying monkeys gave me just really great insight into how humans operate with technology. Not so different from chimps and sticks occasionally. Okay. So current landscape. Oof. Oof. I'm sure we all recognize this map, but if you don't, it's Matt Turk's Mad Landscape, 2023 edition. There are some inclusions of generative AI startups and also some consultants, Seattle data guy on the Mark Data, Mark Freeman, and also our friends over at Ternary, Matt and Joe. So congrats for them to making the map. But this is what it looks like. I know I look at it and I'm just anxiety and panic induced. And I'm sure for many of y'all who are in your buy, build, evaluation phase, you probably feel like this too. That or you're a psycho. So this is what it used to look like hypothetically, right? It might not include everything, but wow, we've massively expanded. Okay, so more options, more tools. That's, always a great thing, right? The jam experiment they did was more jams made people happier, right? It did not actually. That was the outcome. More choices did not, in fact, make people happy. But how did we even get here? Okay, so what was the original promise of MLOps exactly? Starting timer. Sorry, forgot about that. Okay, so MLOps, a lot of people think it basically kicked off unofficially in 2015 with the publication of the high interest credit card debt paper by D. Scully and friends. And then 2 years later, we had the test score paper, which attempted to define a collection of best practices especially software engineering best practices for productionizing machine learning in a way that was scalable, it was repeatable, it was resilient. And essentially, like, we were trying to get to a very seamless pattern of you design it, you train it, and you run it. Essentially, like, if we put it in more technical terms, right, we were essentially trying to figure out, like, or improve 3 different dimensions. The first one was velocity. How fast are machine learning models being developed? How fast are they getting shipped out the door? That's always a good thing, right? More projects, more money for business. Throughput, which is like essentially how much innovation can you just like shove through the pipeline? And third, most importantly, risk, especially in monitoring and evaluation, right? We essentially did not want to put out models that were terribly racist and bigoted. We also wanted them to work. So this was the original sort of goals of MLOps. But sometimes it kind of feels like, I don't know, it feels like we kind of left some folks behind, you know? Sometimes it feels like there's something that's a little bit missing. So we've essentially kind of, in my opinion, we've really failed the original like consumers of MLOps tooling, which was data scientists. Over in MLOps and ML systems land, you know, we've been going gaga over like complex diagrams. We love talking about like, oh, should a notebook be used by data scientists? Should it be put into production? Oh, how fast can we speed up latency using XYZ in memory store? Right? We love all these different topics, and that's fantastic. There's a lot of parts of the ecosystem that we've managed to build out and optimize. Okay, so, but what are data scientists like actually experiencing? Maybe they've got issues with versioning and, you know, lots of different named notebooks. Maybe they have issues with like collecting and creating these data sets, with data transformations and feature engineering. From the perspective of a data scientist, and even from the platform engineers that support them, this is the reality. Insufficient data documentation, tribalism, siloing, dev-prod environment mismatch. These are like, we can go on and on and on. This is just 3 papers that were published on MLOps in the last 2 years. If you're interested in the recommendations, just let me know. And I can tell you like in office hours or whatever. Okay, so there's a lot of challenges. I mean, some of these can definitely be solved by tooling. And I could jump straight into like telling you what stacks I think are really cool. You know, take my opinion or leave it. But here's the thing. In my experiences, both like as an IC, working as a data scientist, working on a platform team, even trying to bootstrap like an early stage, like real estate tech data startup in the middle of quarantine. God, that was just such a bad move. It was interesting, but it was not a great move. So I've had a lot of experiences working with practitioners and builders. And there are things that we could be doing differently, regardless of what tech stack we use, regardless of whether you're using Redis, you're using any other like competitor, you're using Snowflake or DuckDB. There are certain practices we should be doing. So what are these 3 practices? Okay, so the first off is treating the ML platform as a product. Like having that mindset, that's something that really is kind of missing. So what are the characteristics of a product? So when I think of a product, and probably when you think of a product, there's a couple things that stick out. First off, it has an owner and it has users or customers. There are people or teams that are behind it that are focused on, for example, developing it so that it, number one, does what it needs to, right? You don't essentially want your Spotify player essentially acting like TikTok. Well, okay, they're doing that now, but still, right? It evolves, it matures. And ideally, it's long-lived. The iPod or the original iPhone ideally outlived the original creators who then went on to other companies, right? When we think of this as applied to platforms, then that implies a couple things, right? One, it's quick and easy to start. Should be easy to use. Secure and compliant, obviously. That's just table stakes. We're not going to argue with that. There's an internal community. There are people who like champion it. with products, even though they are long-lived in Silicon Valley terms, a platform should be up to date, should be relevant. And a very, very important characteristic of platforms or products is they are opt-in, they are not forced. The minute you try, this is how we get shadow IT, the minute you try forcing something on a data science team or even an engineering team, watch them like try to find, obstacles around it, right? So if we think about our platform as a product, this implies certain things. As engineers, we do really, really well at measuring things like infrastructure. For example, like serving, latency, number of instances, number of like Jira tickets that are filed. We're really, really good at that. We've kind of, figured out a bunch of stuff we could do there. But a lot of times what teams are really missing is these top two layers. For example, when you think of a product as like a growth marketer or a product manager, you're thinking about weekly active users, engagement, adoption rate. I mean, for a lot of platform teams, do you even know like who's using your like platform? Like, do you have that kind of telemetry? Do you know what they're doing with your platform? Essentially, like we've been really good at building out APIs, tools, services, collecting them occasionally into like pseudo platforms, but we kind of like leave out on this unified experience, right? Like it should be all together. People should not be jumping through like hoops as if it's like the old school Nickelodeon battle games or battle shows. Okay, so second thing, this is related to platform as a product. Enablement, right? It's the thing that we all kind of are like, yeah, well, let's just ship it and then we'll kind of like do an office hour and then people will get it. And if they read our documentation, they don't get it, they're dumb heads, right? That's how we think of it. And for a lot of folks, this is how, like data scientists are thought of. They're either thought of as like these like mad geniuses or these people who are like, I paid for a boot camp, why didn't I get a 6-figure job? I was a boot camp grad, so I'm allowed to make that joke, by the way. I'm not just picking on folks, right? So enablement is a very manual process, right? Yes, you have qualitative data and metrics, but you also need to do, or quantitative, but you also need to do the qualitative, like manual approaches, like asking these questions. Like if you don't know the answers to these questions about your users using our platform, I would argue that one, you're not user-centric, and two, you kind of just did resume-driven development. Don't worry, I've been there too. So, but why is it important even to do like user surveys? Why is that like the first thing they tell startups to do in developing a product? Well, for one thing, it's because you might not actually know who your customer or user is. For example, and a lot of folks have probably observed this like themselves, data scientists tend to be a lot more diverse, not only in field of study, so they tend to come from more places, as well as prior job titles, even more so than data engineers. And the third best practice that we need to be doing before we even like think about like stacks or making like decisions is our North Star, right? OG users, data scientists. Much like the talk that's going on about ChatGPT and how like, oh, Copilot is making every like engineer like a 10x engineer. This is what should be going on with our data science like platforms or ML platforms or MLOps platforms, whatever you call it, right? We should be making every data scientist a 10x data scientist. It should be a seamless experience. I said an F word, but I didn't actually. By the way, that's what the pause was. There's a couple things that should be going on. First off, it should be solving cognitive overload. It should be cutting friction and increasing flow. These are the two mandates of platforms. We should not be enabling this. We were just talking about Oracle and this diagram. Okay, so there's a lot of stuff out there. Raise your hand if your platform is basically S3, Spark, and Redis, and Bash, plus Kubernetes. And Python. Yeah, there we go. Come on, guys. I know y'all's like PySpark. Yeah. And hey, you know what? There is no shame in that game. Don't let anyone say that, you shouldn't be using those. Those are great tools, and I'm not going to knock on like that layer of the stack For one thing, I'm not smart enough. But there are certain classes of problems that they don't solve. So roughly speaking, if I were to apply scientific method, right, which this isn't, so there's two different kinds of layers of problems, right? The first problem is, we call it the platform. We're kind of figuring out the name, but it's really like the infrastructure, like the core components, the modules, the services, right? It's things, for example, like Redis, Snowflake, DuckDB, Kubernetes, Ray, you name it. It's figuring out the technical challenges. How do we make it faster? How do we increase the throughput? Yada, 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 right? But there's this other class of problem that lives on top of it, which is like workflows. What is like the right set of operations for how someone should proceed with their model? What is the handoff look like? We all know that we need monitoring, but maybe, for example, people need monitoring at different times. How do we essentially codify these things into a happy path? Right? Specifically, what I'm talking about is the problems around the data science jobs to be done or the problems to be solved. We've been really good about that. So let's dig in a little bit deeper on the ops or how to map tools to your problems. Okay. So data science jobs to be done. Man, that buy, build, evaluation decision thing, it is tough. It's tough, especially and it doesn't matter what stage you're at, whether you're early stage and you're a solo data scientist, whether you're mid-size as a team, whether you're enterprise, the build, buy, best of breed decision is never easy. So what I'd like to do is try to kind of come up with a framework for how I like to think about stacks, which ideally should hopefully help you with tools, right? Okay, so there's two dimensions I like to think about. We'll start with the first dimension, which is the ML lifecycle. So we can kind of separate out the data scientist jobs to be done roughly in 4 stages. So stage 1, which I like to call the data everything stage, or the data set engineering, not to be confused with data engineering and data ops. There's a couple things going on, right? First off, as a data scientist, you are getting your data. You're curating it into a single data set that you can work on. That was one of the hardest problems still, right, in MLOps. You're analyzing that data. You're seeing if there's some initial signals or trends, or even a lot of times if you could just kind of stop the project there and not even go to model mode. Sometimes the best model is the model that's not built. And then you also have feature engineering and feature serving, right? So that's the first step, first collection. The second collection of jobs to be done, or tasks for a data scientist, is the model experimentation and training phase, right? So you have your data, you have your set of features and labels if it's a supervised learning problem. And then what you're doing is you're experimenting with different combinations of the model algorithm, different features, hyperparameter tuning. Sometimes you're even experimenting with ensemble models, right? So you're going to be doing that in that stage. Next, you have your model. You're going to deploy and serve it. Ideally, this should be relatively smooth. I know for a lot of people it's not. And then once you've deployed and serve it, the job doesn't end there. You do want to monitor and evaluate it. And hot take, in case anyone cares. So if you are a company that cares about LLMs, and you're going hard on that, and you're not going hard on monitoring and evaluation, it's called being on the hype train. So hot take there. You should be caring about this stage, especially if you're doing the whole large language models, right? So those are the 4 stages. The second axis is level of abstraction. So the layers go from hard. I'm going to list layers, and then I'm just going to work through an example to make it a little bit easier. Layer 0 is hardware. Layer 1 is your compute frameworks. Layer 2 is services. Layer 3 is workflow. And layer 4 is platform. So let me explain it, and let me kind of work down. So you are a team. You've got your ML stack. So the top layer, you might have a single framework or an integration framework that spans the entire lifecycle of your model. It manages the different kind of workflow layers underneath. This helpfully is like the first unified interface for your data scientists. It also codifies like how machine learning is done at your company. Layer 3, workflows. Let's use the example of the dataset engineering / data everything category of jobs, okay? Which includes the data analysis and feature engineering and serving. So for your workflow, you might have some kind of orchestrator that will manage at layer 3, essentially the transformation that occurs like in layer 2, maybe through Spark, right? Maybe Spark is your like transformation engine. And then maybe you also have like a couple others, right, that are used. You want a single orchestrator or workflow that manages that. Spark, whatever you're using, is essentially, it can live on top of a general computing framework. For example, like Kubernetes or Ray. Very common pattern. That's your layer 1. And then layer 0, it's your hardware, it's your compute and storage, right? So these are the 2 dimensions I like to think about your ML stack. And when you put it together, you start to build out like what are the problems to be solved for like the data science workflows and also to get models to production. Like you start to build out what your actual stack is. I see people want to take pictures, so I'm just going to pause this here so you can. Cool. We'll also release the slides too, so you can get that in more detail as well. But if you want it for now. Okay, so I was like, it might be easier if I walk, but I refuse the lavalier. So, okay, let's just kind of work left to right. So that single example that I was taking of like the feature orchestrator and like the feature store and transforming features and all that good stuff, we're now going to extend that to the other stages of the ML lifecycle. So layer 0 and layer 1, which is your hardware, your compute framework. For example, like layer 0, you might use a cloud provider. For layer 0 and 1, for example, you might use like a serverless GPU provider, like Banana, like Modal. Okay. Roughly speaking, like layer 0, layer 1, that is going to span most of the company. That's just not an ML specific problem, right? Or an ML specific like tooling to be like used. You're going to essentially use like whatever is being provided for your software engineers, for your data engineers. We're not touching that, right? Okay, so layer 2, 3, and 4, that's kind of where the magic of like the ML stack, MLOps stack actually happens. So we'd already talked about the first set, which is the data everything, including like feature engineering. We talked about how like you have your layer 2 services. You have some kind of like feature engine or feature service that's then going to be orchestrated through like a layer 3 orchestrator. Let's then go to the next stage, which is like the model experimentation and training. So at layer 2, you're going to have some kind of like training service or framework. Might be PyTorch, might be what have you. You might, for example, use, you might want to do experiment tracking for hyperparameters, right? So essentially that's something that like has to be done. A data scientist has to train the model. They have to be the one to run the experimentation. It's not a data engineer. It's not like, it's ideally not the MLOps engineer either. It's not the platform engineer. And they're going to essentially like need help with that workflow. They're going to essentially need help like using that service, using some kind of like workflow orchestrator or the experiment like management service or workflow. Sorry, I'm mixing up the terms. Yeah, I'm tired. Next stage, stage 3, which is deployment and serving. You're going to want some kind of path to production, whether it's, for example, like your model as like embedded in a Docker container or what have you. And you're going to want a service to like help manage that and so on and so forth, right? Just to make this like super crystal clear, I've put some examples up here. So for example, your services would be like DuckDB, Redis, Cassandra, Snowflake, Spark. For training, your service might be like DesAI with their super gradient, library, it might be Mosaic. For your deployment and serving, you might have like Selden Core. You might use BentoML. For evaluation, YLogs, Logstash. And then you have a bunch of these workflows that live on top of that, where ideally they can connect with multiple different providers within the lower layers. And then at the top, you have like the orchestrators of orchestrators or the super orchestrators. So Kubeflow, Flight, Metaflow, ZenML. There's a bunch that I'm missing, but you know, like there is a lot of logos on the Mad Turk landscape. Okay, so like I had promised some stacks. Okay, so let's talk through how we're going to essentially like apply this framework and also see kind of where it breaks down. Okay, so needs of the solo data scientist. Who are you? Well, the solo data scientist ideally is, they're not like the very first hire before a data engineer, but they might be. They might also be, they are definitely being hired before there is like a centralized platform effort. I've been in those shoes. I know a lot of folks here probably have. So your goal as a data scientist is you're trying to prove immediate value, like with minimal overhead for your startup, right? You're just trying to ship stuff in a way that doesn't totally break things. You're probably also not in a position to frankly make build buy decisions. You're just like, I gotta like go. So you have a couple different needs that are super, super important at this stage. So for example, you need to keep track of your own stuff. Like you need to make sure your house is like super clean. Data model, code artifacts, including experimentation runs. And ideally you'd like to do it in a way where you're not naming a bunch of notebooks and you have a bunch of like GitHub gifs going like, oh yeah, go do this. So you need versioning and documentation. You need a way to quickly like iterate between features, algorithms, and like tuning. You need experiment tracking, sure. But you need to like be able to just kind of go on your own accord. You shouldn't be blocked, ideally. You need to train models on like a large enough amount of data with access to GPUs, probably, if you need that. And then you need to do everything with the least amount of overhead possible, with least amount of steps. And a lot of times you're on an island, you're on your own, engineering is not going to help you. They're just going to be like, go figure it out. So I like to call it the Duke Nukem stack. This is maybe dating folks already. I can see who the Gen Zers are. Okay. All these stacks, by the way, it's not gospel. I'm just giving an initial set of guidelines, right? Okay, so what are the characteristics of the Duke Nukem stack? Well, we mentioned a couple things, right? One is minimal overhead. Two, compatibility with the existing product stack. Your efforts should not be like severely diverging at this point. And the hot take is like, yo, notebooks are fine. Okay, let's just chill out on that. Those are not the arguments we should be having. A couple different features. So if we go like left to right, and then also top to bottom right, layer 0 and layer 1, you're not making decisions there. But you still need access to computation. And you could do this in a number of different ways. I've listed some folks here that are like notebook based, right? We have Paperspace, we have Colab, we also have Code Spaces is an option. If we look at layer 2 and layer 3, for your data storage needs, you're just gonna use whatever your company has, or you could use, for example, like DuckDB for like your small enough data, small enough and big enough, right? You might want to like track your features. You might want to document them. You might also want to serve them for future models. So you could use a feature store like Featureform. It's open source. Actually, everything here for the most part is open source, except for the stuff that two areas where you like pay for effectively, right? For computation. Renting time is not cheap. Yeah. And then, okay, so we go to model experimentation and training. Look, like I said, I think notebooks are fine, honestly. You're going to want to use a tool like Comets or WANDB for experiment tracking. Both those are perfectly fine. You're not super worried right now, honestly, about like your model registry. You can park it in an S3 bucket, whatever. It works. Okay, so for deployment and serving, you're ideally not doing anything super fancy with this. You're not doing real time or streaming. You're probably going to be okay with like a batch prediction where, you know, like you make the predictions and then you just do a lookup from like a table or a cache of some kind. You might do like a live service if you want to containerize it, but it's not like super necessary right now, right? You're just proving business value. You're proving the initial value of using ML for your product, for the company. But you'd still like a path to deployment. And so Bento ML, it's an open source solution, is totally great for that need. And then same deal with like monitoring and your logs. You probably just need something that the company already has or that's good enough for now. And you could use something like Logstash. And for your CI/CD, I mean, use whatever they have. Once again, it could be Jenkins, it could be like Travis CI, BuildKite, or GitHub Actions. Okay, so that was the Duke Nukem stack. Not super sexy or exciting, given the name, but it works. And surprise, that's going to be like all these stacks here. Like, they're pragmatic. They're not super sexy. I'm not trying to shove like totally new things at you. Okay, needs of the SMB data science team. So, who are you? Well, minimum, you probably have like 5 data scientists. It's a good number. Y'all are collaborating. You're sharing knowledge. And things like that. Minimum, like, let's say 5 data scientists, maximum, maybe you're like at the 10 data scientists and you have like a single director, right? Okay, so what are your needs going to be? Well, first off, you've got a bunch of different people that ideally are working with each other. They're collaborating. And of course, tribal knowledge and silos start developing kind of at this stage pretty quickly. So you need help with collaboration. You need to be able to like show the work in progress. You also need to be able to like document the work. So you're not being pinged in Slack going like, hey, by the way, does anyone remember like this table that tracks like user click streams off of like, you know, Google Analytics marketing campaigns and all that. So you need like a place to get async knowledge. And for new people to like immediately get started. Who had that like experience of getting started at a company and then they're like, oh yeah, just go check Confluence, and no one. Confluence is where knowledge goes to die. You also need to ideally you'd like to share and reuse like sources. You don't want to be rewriting the same like data pipeline over and over again, and then racking up whatever like bills. Fine-grained monitoring evaluation. This is where it is actually going to start to matter, because with 5 data science, for example, you have at least 5 models. Sometimes some of our customers even have up to like 100 for like 5 or 10 data scientists. It's crazy. You're really going to need fine-grained monitoring. You're going to need to find out, first off, which models are misbehaving. You're also going to want to figure out like how are the conditions changing, like detecting data drift before they screw up. So let's talk about the serious business stack. Okay, so how's it different from the solo data scientist? Well, there's a couple different things. One, you might start really differentiating the kinds of providers you have, including, for example, you might have an offline and an online store provider. You might also be selling behind a couple different frameworks, for example, like Spark, but you might add others too. There are others that exist outside of Spark. So you're going to need a solution that is able to start mapping the multitude of providers you're going to start developing, especially on the data side. So you can still use Featureform for that. Okay, on the model experimentation training side, so this is where we start seeing differentiation in terms of the types of like serving patterns. So it's no longer just like batch, but maybe now you also need like a live service where you have a pre-trained model that you then expose behind like an API endpoint, and then that needs to provide like real-time stuff. Like let's say, for example, you need like recommendations like as you're like shopping. Awesome. And then, so you're gonna have a couple different like serving patterns as a container. You might still do batch. You're gonna want to start really thinking about the layers 1, layer 0, about the general computation frameworks. A very common pattern that we're starting to see now actually with our customers is using like Ray on top of Kubernetes. You're still gonna want to use something like Bento. Bento also has an option called Yatai. So that's going to be really good for scaling on Kubernetes, Y Labs, etc. But The key part though is you're going to want to start thinking about that unifying framework, right? Because now you have like 5 to like 10 data scientists. You're going to want to start codifying the way the company does things. And so you can use a framework like ZenML and some of the other ones I mentioned too earlier. Oh God, enterprise. Yeah, we all remember what that was like. Okay, so what's going on? Like everything. Enterprises have like many of everything. They have many store providers, many products, many monitoring solutions, you name it. So they have a very heterogeneous infrastructure and data. Governance, access, control, audit logs. Okay, so basically like you start worrying about things like GDPR, HIPAA if you're in medical, CCPA. You really start getting worried about being sued. And it's funny because there's even like less transparency in enterprise. So you have more risk, but you also have no real way of like figuring it out. Hypothetically, law of tools offer that now. Cross-functional workflows is really important. You start seeing, for example, like pods, data scientists embedded in product teams, and you start getting that like super heavily matrix company. When I was over at Autodesk, they had a layoff that laid off like 13% of the workforce, and we still had 53 products after that. Before that, we had 70 plus, and they have built stuff, but most of the companies were acquired. So it was a mess. If there was a stack, we would call it the Ollie Ollie Oxen Free Stack. This is what my boyfriend says every single time I go into a handbag shop. So, okay, there's no stack here. I lied. No, but this is to say that like you can still apply like the framework to kind of figuring out and mapping the tools to your requirements. It's just usually as a team, you're probably, I don't want to say you're siloed into like one area of the stack, but you just have to like think more strategically about like, okay, I have this pain point or bottleneck here and I need to now solve out or up or down. So just hopefully this provides a map to how to get there. Okay, so hot take, there will be no modern MLOps stack. I know I'm making everyone sad, but I think this is like a very, very healthy thing because a lot of companies, they do have truly unique requirements and they're at different stages. And honestly, my whole point with this talk was I had a conversation with someone on Twitter who was like, she was asking like, well, what's the need for a feature store, right? And she's like, isn't it just like for real time? And if you need XYZ things, I'm like, yeah, sure. Like the initial, like all categories of tools, right? Model training, experimentation, evaluation, the data set engineering section, right? Yeah, like the MLOps tools of 5 years ago, yeah, they did look a certain way, but they have updated now, and you know, options are good, but they can be overwhelming. So I hope, honestly, if there is anything you take away from this talk, it's honestly just that like table or that framework. So in closing, we talked about all these things, but look, it is really confusing. And the beautiful part is, as like a product developer or as someone who wants to do ML as a business, you have so many more tools to be able to do that. But more importantly, as practitioners, if you're a platform engineer or a data scientist, like you have the knowledge necessary to pick your own tools for yourself. I know it's ridiculous to think about like MLOps in a notebook, but that is 100% doable, right? MLOps doesn't have to be this big, scary thing that is mandated by a company. It can be something you just do for yourself, right? Especially for the solo data scientist stack. Like I use that like on my own too, right? So there is hope. And more importantly, you can get involved in the open source community. You can help build, contribute. You can kind of create the future that you'd like to see. Yeah, and that's it. Feel free to chat with me during office hours and QR codes. Connect with me on LinkedIn. So yeah, that's done.